All right, so continuing with our introduction to integration, whereas last time the focus was more on using technology to calculate these integrals, we want to start looking at a bit of an algebraic approach, essentially looking at the reverse of the power rule that we learned earlier on in the calculus unit. And so if I look at function f of x here, 3x to the power of 4, if I want to find its antiderivative, our convention is we use the uppercase letter compared to the lowercase letter here. This means I want to find the function whose derivative is 3x to the power of 4. And so I don't want to differentiate it, I want to anti-differentiate it. And it's the reverse of the power rule. So keep in mind for f of x, if I want to differentiate f of x, we would take our coefficient, move it to here, and then subtract 1 from the power. In this case, if I want to find the antiderivative of it, first I'll use the capital letter F. The 3 is my coefficient, that will stay there. That's it, it's going to be x, but I'm going to add 1 to the power, so it'll be to the power of 5. And whatever power I have there, I now divide by that as well. And in this case, I'm done. I could write it as well as 3/5 times x to the power of 5. And if you're ever unsure, the good thing about the power rule is it's very easy to double check if you're correct. And notice if I'm correct, I should differentiate this and get that. And notice if I differentiate this, the 5 goes right here, cancels out with the denominator, and my power goes from a 5 down to 4, which is indeed correct. So that's the nice thing about this. Even if you're a little unsure, you can usually check quite quickly. For the antiderivative of g of x, before I actually do that, I first like to rewrite g of x with a negative exponent, so 3 times x to the negative 4. Because whether I'm differentiating or anti-differentiating, in this form is quite helpful. Now, same idea. I want to find the antiderivative. My coefficient, I'll leave as is. X, I want to add 1 to negative 4, which is negative 3, and whatever power I have there, I write here as well. In this case, it can be cleaned up. My coefficients cancel out, and so I have just negative x to the negative 3. Or, of course, I could write that as negative 1 over x to the positive 3. Again, they're all good. We should understand our negative exponents at this point. So those are the antiderivatives. Again, negative 1 over x cubed is the antiderivative of g. If we're asked for the indefinite integral, it's essentially the same thing, just we have to realize that there could be a constant here. For example, if I put plus, 7 at the end, and I differentiated it, I would still get to that same function of g of x, because that plus 7 being a constant, when you differentiate it, you get a 0. And so all we got to remember, just kind of convention here, is that if you're asked to find the indefinite integral, which looks like this without any bounds up or down, we are essentially looking for the antiderivative. We just want to remember that there is a constant value that we want to include as well. And so the antiderivative of 3x to the power of 4 dx is going to be the same answer I had up here, 3/5 x to the power of 5, but plus a constant. And generally we use a c for a constant. And really, because any number that would go there, any constant number would go there, would lead to this derivative here. So this antiderivative, we say, this is the family of all the functions that have a derivative that leads to, the derivative that would lead to there. So that's really the only difference. And so same idea for this. If I want the indefinite integral of 3 over x to the power of 4 dx, again, same answer I came with up here. I'll write 1 over x cubed, but again, plus some constant. And you may think that plus c is not that significant, but it's very significant. And it's easy to remember. It's also easy to forget. And so just don't underestimate the importance of that. And lastly, if I want to find the indefinite integral of these two added to each other, well, then that's the same as just finding the indefinite integral of these separately. So the question here will have the same answer as just this. And so I can just take my answers from above, here and here, and just put them down here. The only difference is I don't need to have 2 plus constants here, and so we generally just put those constants together, and so I can say this answer would be 3/5 x to the power of 5 minus 1 over x cubed, and then plus some constant. You could put plus some constant plus another constant, but again, that's kind of silly because they add up to just some other constant. So in general, we just do that. And so keep in mind, again, much like when we differentiate, if we have multiple terms that we're finding an integral of, or we're trying to integrate, we can just break them up into the individual terms. All right, so here I want to start thinking backwards. It's a little more abstract of a question, but eventually I want to figure out function f. And what I'm told first is I'm not told what function f is, but I'm told what its indefinite integral is, or essentially I'm told its antiderivative. As well, I'm told when x is 1, f of x equals 3.5. So first let's look at this indefinite integral. And so keep in mind, this here, if I can figure out what that is, I know most of my equation. I just won't know the constant. So let's find this indefinite integral. Let's find this antiderivative. And so first, what I would do is I would take this function here, and instead of writing it as a rational expression, I would break it up. And so let me take the integral of x to the power of 5 minus 3 and show each of these being divided separately by x to the power of 4. And then in doing so, realize that x to the power of 5 over x to the power of 4 is just x minus 3 times x to the negative 4. Which, notice, we actually had in the last question. Dx I should have here. And so I can now integrate these both separately. And so the integral, the antiderivative of x is x to the power of 2 divided by 2, minus the antiderivative of 3 to the x over negative 4. Well, that's, again, what we did up here, right? Did it right here. So I know it's going to come to negative 1 over x cubed. So minus negative 1 over x cubed, or save myself a bit of work, plus 1 over x cubed, plus a constant. And so keep in mind what we see here is that. That is the indefinite integral of x to the power of 5 minus 3 over x to the power of 4. So that is my function. That's f of x. However, I still have that constant. I don't know what that constant is, and that's where this comes into play. I know when x is 1, y equals 3.5. Or I put in a 1, I get out a 3.5. So that means I know if I replace all these x's with a 1 squared over 2, plus 1 over 1 cubed plus some constant, I know I'm going to get 3.5. Put in a 1, get out 3.5. And now I can quickly solve for c. I get a half plus 1 plus c equals 3.5, which means I get 1.5 plus c equals 3.5, which means c must be 2. And so now I know my entire function. So I can say, therefore, f of x equals everything I have here, x squared over 2 plus 1 over x cubed, plus I now know the constant is 2. So there is my final answer. Keep in mind, if I was not given this fact right here, it would be impossible to know what that constant is. Last question, similar idea, deceivingly tricky, but in the end we're trying to find a function and we're not told its equation, we're told its derivative, and we're told that this point, this function y equals 4x plus 9.875 is normal to the graph at some point, but we don't even know the function. That's it. There's lots of approaches. Let's first focus on, let's focus on this first. So that's the derivative. I want to find its antiderivative. And so let me take f prime of x and rewrite it as 2 times x to the negative 3, which means its antiderivative, this already is f prime, so I can just say f of x. The antiderivative is going to be 2 times x to the negative 2. We add 1 to that, and then we divide by that power. Clean this up a bit, I get negative x to the negative 2, or negative 1 over x squared, plus a constant, right? And if it wasn't for that plus a constant, it seems like we're done. We don't want to forget that we don't know what that constant is. So now most of our work is figuring out what is that constant. Okay, well, let's get to this. We know the line 4x plus 9.875 is normal to this function here at some point. We don't know when that point is. We can figure it out. So keep in mind, if the line is normal, that means this line here is perpendicular to this function at some point, which means the slope of this line is the opposite reciprocal to the slope of this function at some point. Let's think about that slope. The slope we're looking at is not 4. The slope we want to look at is perpendicular to that. So we want a slope of negative 1 over 4. So at some point, this function f of x, or this function here, at some point it has a slope of negative 1/4. We need to find out where that is. Well, slope has to do with the derivative. And so now I want to come back to our derivative, actually, and figure out when does my derivative equal -1/4. So let me erase all my scribblings here, and let's do that. So let's go back to my derivative now, which again, I'm going to write as a fraction. So f prime of x was 2 over x cubed, and I want to find out where this equals -1/4. So let's solve for this. Pretty quickly, I know that x cubed must equal -8, solving for x cubed. Right, I'm essentially just cross multiplying 2 times 4 divided by -1, or however you want to approach it. Cube root both sides. And I get, that means x must equal -2, which means when x is -2, this function here has a slope that's -1/4. Or more importantly, when x is -2, this function here crosses this normal line. So I know the x value, I now need to find the y value. I still don't know what this function is, so I can't put -2 into that, but I do know it meets the normal line at that point. So I can put this -2 into my equation here. Because at this, when x is -2, my normal line and my function f cross each other. So now let's look at that. Let's look at y equals, instead of 4 times x, let's put -2 into there. And pretty quickly, I get y equals -8 plus 9.875. Or when I add it together, I get y equals 1.875. So I now know when x is -2 and y is 1.875, my function here has a slope of -1/4. Sorry, my function here has a slope of -1/4 and crosses this here. So now that tells me, therefore, that for my function, oh, I've circled so much stuff here, but if I now go to this, because in the end, remember, we're trying to figure out, for the last few minutes, we've just been trying to figure out that constant. I now know for my function f, when x is -2, this whole function here equals 1.875. And now I have enough information to solve for that constant. So let's make this a little bit neater down here. So I can say f at -2, I know equals 1.875, or in this case, to go to my equation, I know that if I take function f, which I can see up there is -1 over x squared, so -1 over, instead of x squared, I have -2 squared, plus some constant, I know will equal 1.875. And notice the only variable is c, so I can quickly solve for this. If I do this, -1 over -2 squared is -1/4. So I get -0.25 plus some number equals 1.875. Add 0.25 to both sides, and we got our constant. C, the constant is 2.125. And so I can now answer the question, because the question is, what's my function f? And so if I look back up here, I now know what my constant is. Instead of -1 over x squared plus c, it's -1 over x squared plus 2.125. So let me just formalize that here. Therefore, f of x equals -1 over x squared plus 2.125. And keep in mind, of all this work here and highlighting and scribbling and whatnot, it was almost all just to find that constant. We had this part here done almost immediately. The rest was all trying to figure out logically how we could figure out that constant. And that was a tough question.